Okay, so we are looking at new types of graphs that look totally different than anything we've ever done before, and they are called quadratics. So I think you have a blank set of notes in front of you that we are going to look at. It should look like, it should look something like this, I think. And if you don't have it, that's okay. Just write it down on paper. All right, so it should look like this. Now, everything we have learned up until now has been something we called linear lines. So they were straight. They went on an angle. They kind of looked like a mountain. And our new ones are going to be called quadratics. So let's take a look at linear and remember what we know. So the formula for a linear line that we always use is y equals mx plus b. And the really important piece of this is this x. And the exponent on that x is a 1. We can't see it. The line is straight, right? A linear line is a straight line. And if we have a formula, like let's say we've got y equals x plus 2. If that's our function, we would make a table of values and we would say like -3, -2, -1, 0, 1, 2, 3. And we would plug them in. So we would substitute this x in here. And side note, I just made the x's up. X's can literally be any numbers you want to use. And I just decided that these seemed like easy numbers. So I'm going to plug those x's in, add it to my 2, and that should tell me what the y is. So -3 plus 2 is -1, and -2 plus 2 is 0, and -1 plus 2 is 1, and 0 plus 2 is 2, and 1 plus 2 is 3, and 2 plus 2 is 4, and 3 plus 2 is 5. Now these all make coordinates, right? Like this could be rewritten as -3, -1. And you could go over here and you could graph this. I'm going to make it bigger so I can see. -3, -1. So I go over -3 and down 1. And then over 2, down nothing. Over to -1, up to 1. Over to 0 and up to 2. Over to 1 and up to 3. Over to 2 and up to 4. Over to 3 and up to 5. And then when you connect these, you get a nice straight line. And that's great. Linear line. You've done it 100 times. Okay, so our new stuff is called quadratics. And this formula looks different. This formula, I'm going to erase this circle I made because it's in my way. All right, this looks a little different. And it has a formula that is crazy, and it is y equals a x squared plus bx plus c. Now, let's discuss the fact that we have x showing up twice. So it doesn't always appear twice, but it usually does. And there has to be an exponent of 2. So the biggest exponent on x is 2. If there's no 2, then it's not quadratic. It has to have an x squared. The line that we're going to make is going to be U-shaped, and it is called a parabola. So let's look at what this looks like. Okay, so we're going to let's do y equals x squared minus x minus 2. All right, so like this -2 is the c, and what number is written in front of the x that's the b? It's a -1, and what number is in front of my x squared for a? Also a 1. That doesn't matter right now for what we're doing, but those are those numbers. Okay, I'm going to again pick -3, -2, -1, 0, 1, 2, and 3. All right, so you're going to plug these x's in here, and you're going to put them in twice because x appears 2 times. So this is going to look like this: negative 3 squared minus negative 3 minus 2. So if you do that, 9 plus 3 is 12 minus 2 is 10. So if x is negative 3, y is 10. Do it again for negative 2. Negative 2 squared minus negative 2 minus 2. So that's 4 plus 4 is 8. 8 minus 2 is 6. Negative 1. Negative 1 squared minus negative 1 minus 2 is 1 plus 1 is 2 minus 2 is 0. 0. 0 squared minus 0 minus 2 is negative 2. 1. 1 squared is 1. Minus 1 is 0. Minus 2 is negative 2. 2. 2 squared is 4. 4 minus 2 is 2. 2 minus 2 is 0. 3. 3 squared is 9. Minus 3 is 6. Minus 2 is 4. Did I do that right? 3 squared is 9. I didn't do that right. Yeah, 9 minus 3 is 6. 6 minus 2 is 4. Okay, now we're going to go graph these things. All right, I'm going to go over to negative 3, and I'm going to go up to 10. So there's 1. I'm going to go over to negative 2 and up to 6. I'm going to go over to negative 1 and up nothing. I'm going to go over nothing and down to negative 2. And then I'm going to go over to 1, down to negative 2 again. And then I'm going to go over to 2 and to 0. Then I'm going to go over to 3 and up to 4. All right. Here's what I'm getting. Although I feel like I have a mistake in here. Oh, I totally have a mistake in here. It's right here. Negative 2 is 4 plus 2 is 6 minus 2. This should be 4. Okay. Do you want to know why I knew that? Because do you see over here? I want these to be like symmetrical. See how these are right here and these are here, and then this should be here. Like my pattern's missing, which said, oh, good boo. You don't know how to add. You're right, I don't. That should be there. Okay, so once that's fixed, you can see that we're creating a U shape. You can also see, if you look really closely in here, that I even went down a little bit lower. That's because I know I need a U shape, and I can't draw straight across to connect those. That would be flat. U's are not flat on the bottom. So that means there must be another coordinate under here that I just didn't happen to have in my table of values. And that's okay. I know it's there. Just like I know there's a coordinate here, and that wasn't in my table of values. So I'm going to sketch my graph so that it's U-shaped. These are what quadratic functions or quadratic equations look like. They always have an x-intercept or a square on the x, and they are always U-shaped. And this one is what we call opening up, like it's smiling. They can open down. That is also an option. All right, now, there are some very important parts on this that we're going to label really quick. First and foremost, how many x-intercepts do we have? We have 2 of them. These are called x-intercepts, and they are super important. So I want you to label that we have 2 x-intercepts. They're very important. We also have a y-intercept. It's right here on the y-axis. This is our y-intercept. And if you will notice, where is that y-intercept? It's at -2. Guess what else was at -2? That was the last number in our formula. So that means that the c is always our y-intercept. All right? Now, there's one last really important piece on here, and it's at the very bottom. We didn't graph it here, but we don't know the exact coordinate, but we can see it. And it's at the very bottom, and it is called the vertex. So the vertex is either the very top of our graph, or in this case, the very bottom of our graph. So every time we look at a quadratic function, we will be looking for these three things: the x-intercept, the y-intercept, and the vertex. This format right here, ax squared plus bx plus c, has a name. It is called standard form. So standard form is ax squared plus bx plus c, and the c is always your y-intercept. You can always make a table of values, pick any x's you'd like, plug them in, and they will help you compute your y values, which then become coordinates that you can plot, connect together to make a U-shape, and find your parabola. Okay, that's it. You're geniuses. This is a big deal to have this down. Okay, see you tomorrow.